The volume of data is constantly increasing. People are looking at things from a higher and higher level, and processors just aren't keeping up. That's why it's really interesting to see so many accelerators being brought to the fore. We're here at Cloud Field Day, recording this episode of the On-Premise IT podcast, On Premises, and we've just heard from a number of companies, among them a company that's making a SQL accelerator, a company that makes networking hardware, a company that makes advanced storage systems. All of these things are designed to accelerate everything that we do. That's what we're going to talk about today on the On-Premise IT podcast. CPUs just aren't cutting it anymore. That's the topic of this episode of the On-Premise IT podcast, brought to you by Gestalt IT and the Futurum Group. I'm Stephen Foskett. Welcome to the On-Premise IT podcast, the only show that dares to be both on-premise or on topic, and yes, today on premises, on location here in Silicon Valley at Cloud Field Day. We have just spent 2 days talking to companies, listening to companies, learning about the latest in technology in the cloud. And it's funny, you'd think the cloud was all about software, but it sure sounds like it's all about hardware because there is a lot of specialized hardware out there keeping up with the workload. So before we begin on that premise, let's meet who's on the panel today.
Hi, I'm Thomas LaRock. I am a data professional, technical advocate, and I'm known online as SQL Rockstar.
Hi, I am Shala. Many may know me across social media as Gifted Lane. I like to think of myself as a cloud advocate, and I'm excited to be here for Cloud Field Day in person.
Hi, everyone. I'm Jim Czuprynski. No, you can't spell that. And I'm an Oracle ACE Director, Oracle DBA, many years in IT, and I am Chief Storyteller at Zero Defect Computing.
So here's the thing. All three of you come from basically software focus. And yet, when I asked you, what do you think was the theme? What do you think was the organ? There was a lot of hardware talk. Are we living in an era where CPUs and hardware and software and everything, where the conventional computers that we've all used, they just can't keep up with the workload anymore? And we're going to need all sorts of specialized hardware now. What do you think?
No.
All right, there you go. There's your answer. And that was this episode. No,
No, I just think we're in one part of a cycle because it always goes around and around where hardware will make an innovation and then people will write code to take advantage of the new hardware. And eventually everything hits a cap and then it just comes back around. That's where we are right now.
I have to agree.
You don't have to.
No, I don't, but in my spirit, I'm just not fully buying into, oh, well, the issue is hardware. So if we buy all this hardware, it's gonna fix your problems. And it's nah. There's some stuff you gotta do at the software level too.
Yeah.
So
Though the most interesting thing that I heard over 2 days, in my opinion, came from Broadcom. And I never expected to say that, about a chip on a NIC somewhere. But in a way, they are building stuff specifically to handle problems that we really can't handle inside a typical compute node, specifically being able to intercept in real time a packet that might be suspicious or that based on a neural network pattern, machine learning pattern, that has been identified sufficiently with the possible false positive as a deleterious packet. So they are building stuff at that level, at the per packet, not per sampled packet level. So obviously they are building hardware to handle problems that we never really thought we could handle with particular types of hardware before. So I disagree, no, yes. Sorry.
There you go.
And the thing with what you're speaking of to what Broadcom showed to us today, I'm excited about it, but I would be even more excited about it if I could get more into, okay, who are the customers? Or with some of the customers, does that involve the CDNs? Because that's where my heartache is. Working in cloud, everyone who knows me, network is my first love, cloud is my second. in current, right? But I still do a lot of networking in the cloud. And one of the things I face from day to day in the cloud is DDoS attacks. And I'm always having to give feedback to the CDNs to say, hey, here's the behavior or the pattern that I'm seeing. They then go and they add it to their stuff, to catch it. And so with Broadcom's, hardware, it would be nice if some kind of way that gets featured with CDNs where maybe they're using it and then the CDNs are collectively working together in a simplified explanation, the same way how you have like Norton or something like that. And all of that, gets aggregated and shared across globally. That would be nice. It would make my life easier.
Interesting. And to kind of echo back to that, I was just thinking, I was at a particular Tech Field Day event where we were actually talking about storage having issues with deleterious workloads and about how it had been for ransomware. I do not remember the exact vendor that was talking about this, but they would say, okay, we're just going to encrypt the whole disk. And now they've gotten more and more sophisticated where we're not going to encrypt the disk, we'll encrypt parts of this file and you won't recognize it until you try to go back and do some sort of access, right? So I can imagine, for example, in a database or a file that you're accessing that is 5 years old and you haven't touched it at all, that's what they go after and mess with you, and you don't even know it's sitting there. So the exploits are getting more and more sophisticated, and it's exciting in my mind that we're recognizing that we're not powerless. And the chip manufacturers and the hardware manufacturers are acknowledging that and are providing us with the tools. If they would just tell us who those tools were being used by, I agree.
Well, I'm going to go out on a limb and say that the Broadcom chips are probably used by everybody or almost everybody. I mean, that's the thing. They're the I don't know, the Intel of networking chips.
Yeah.
And I feel like that's a nice segue. Speaking of Broadcom, because we did see, and I think you would have some opinions about this, where we got to hear about SPUs and what did we see on that piece of hardware.
A Broadcom chip, yep.
You're right.
Along with a proprietary chip. So Tom, tell us a little bit, what is an SPU?
SPU is a SQL processing unit. I didn't know it existed until yesterday, and now I want one.
Right? Exactly.
It's a piece of hardware that is designed to speed up analytical queries.
Yeah.
As long as you have an analytical platform, and a lot of companies, if you're in that space, you already have that. So if you're using Spark or Presto, then it just interprets that language and it can process the queries even faster. And it looks brilliant, and I'd like to know more about it.
So it's interesting that what you and Shala are saying is essentially you're talking about hardware that is specifically designed and optimized to understand or to specially process specific workloads, right?
That's right.
Right.
Yeah.
And that's the world that we live in now. I mean, I think that if you talk to Intel, for example, their thought seems to be that you have a CPU, but then you have all sorts of accelerators all throughout the workload. That's certainly what we were hearing from companies like VMware. That's kind of how they're trying to do things. That's what we're hearing from, that's like basically NVIDIA's entire universe is building, awesome hardware for specific use cases that just could never be processed normally. So is that the world that we live in now? We don't live in a monolithic world where you've got a CPU now. We're living in a world where you've got this distributed, specialized hardware, right?
Mm-hmm.
Yeah.
We are, yeah.
Well, then how come you guys disagreed with me when I said that at the beginning?
No, I don't think I disagreed with the specialized hardware. I think I disagreed saying that it was
The fix-all?
the fix-all, because it's not. It's just temporary. You're just moving the wall slightly, and now eventually somebody's going to come up with the right idea of figuring out a way to write code to make it to take advantage of those things.
Yeah.
That's all.
And hear me out, but I almost feel like because I live in the DevOps world, I feel like there's a new term or culture that needs to be created where it does what we did with DevOps. So you have like operations and developers and you merge that in the infinite loop. We need that between software and hardware.
Oh, wow.
is
would
what
we
I'm
call
thinking.
What would you label
I
that?
don't
You could
know.
call it, you could combine the first half of one word and the second half of the other word. You could call it software. No, that doesn't make sense. Oh, no, you could switch it. You could do hardware. No, that one doesn't work either.
Soft ops.
Let's not
Soft
call it
ops.
soft hard.
I know. I thought it, but I was like, I would keep that to myself. That's for the Twitch channel.
No, but that is actually a really cool idea, because essentially that's the world we're living in, where you've got software, you've got hardware, they're kind of pulling in different directions.
Yep.
If only they could kind of synthesize that into a thing.
I want to live in that world.
Firmware.
So hard sec ops, something like that, or I don't know. Squishy, hard squishy.
What
Soft.
what do the people out there think? I'm curious. What are some
Yeah,
ideas
I
you
would
all
like to-
have?
Yeah, we should ask them, and then they could respond to this.
I think
Yes.
I think it
just
would be a
did.
good idea. You can put that in the comments, folks.
Yeah.
Yes.
Believe, we'd like to hear it, seriously.
Yes.
So what would that look like? What would it look like if we had a future world? And I think the companies are kind of dancing around this too, because if you talk to companies that are making a lot of these things, I mean, you heard about P4, which is a programming language for network processors.
Right.
And I forget what was the name of the Broadcom one.
Looking.
MPL.
NPL.
NPL.
Thank you.
Yeah,
Yes.
You're
that's it.
welcome.
And there again, I mean, you've got specialized languages for a specific piece of hardware. Obviously, NVIDIA's crown jewel is CUDA. Again, special language for a special purpose. So there is really kind of a software-hardware integration going on, right?
Oh, yeah.
The thing that I find interesting across all these presentations is it seems that we've stopped trying to get, from a SQL perspective, right? We can talk about this. We've given up on getting developers to write better SQL.
I gave up on that
Start
years
there.
ago. I mean, that's not something that's
Start there.
Yeah.
But it's just like, isn't it IT organizations basically admitting our people really don't care, and they're either not intelligent enough or not devoted enough to their craft to make it better?
No, they're not.
Or is it
There's not enough
not to be
time.
picking on anybody?
No, there's not enough time to
do it
acquire
right?
all the skills necessary to keep up with everything.
Okay.
There's not.
Like, I'm a data platform MVP, but if you think I even know, everything that goes into there, 20 years ago, I could know a lot about it because it just didn't, there's just so much more that exists today. So
I hear you.
It's hard to keep on top of all that. And if you're somebody new, you're coming out of school, you're a developer, you just need them to write some code that compiles and works.
Yeah.
Right.
The idea of being up to date on all the things that they can take advantage of, that's not going to happen. So that's why we can laugh and say, no, developers never going to write the code well enough. They're not taking the time to understand how a relational database will actually process a query. And you know what? They don't need to.
I concur. And optimizers are much smarter than they used to be even 5 years ago. I agree with you. It's interesting, too, back to your comment about, not to take this into a strange tangent, but I was talking with someone at what's called Oracle Academy, and one of the interesting things that we're trying to do is get people in school right now interested in using legacy hardware and software. What we're hearing from the university perspective, are you ready for this? The university professors and teachers are teaching people stuff that's 5 years old. And so the stuff that's happening today, they would never even have heard about whatever's going on with what Broadcom, is doing. They're still maybe, I don't know, writing Fortran for all I know. So I mean, it's frightening.
It's Python, but
Yeah.
Python 1 probably or something. But again, we don't have time for that. We don't have time to do it right. So, but we'll make time to.
We'll fix it later. Yeah, that's fine.
So my kid just graduated with a computer science degree a couple of years ago, and they absolutely are not teaching them. I would have guessed that they would be deeply into the open source programming. I would have guessed that they would be, teaching them all these, modern languages and stuff. It really wasn't. It really wasn't a lot of that stuff. It was, kind of the nuts and bolts of computer science, and the thought was basically you can figure out the rest once you know the basics. And this was somebody with a data science focus. And so, they were talking to them, a lot of Python, and not a lot of systems administration or database administration or networking or anything like that. I don't think that I'm not trying to gripe about education, but I think that it gets to the point that we were saying that, basically If people don't optimize the software, then the hardware has to optimize it for them, right?
Yeah.
So, but I think the purpose of the education isn't, for example, coming out of school today, do you think a student should be well-versed in Go? Probably not. I think teaching in Python is enough because it's more about the analytical reasoning. Being able to debug code, I don't care what language you're using. What's the thought process on how you're going to resolve that error message?
Yeah. And plus a new
that's what
language. Sorry, because I was going to say, plus there's always going to be like some new language is going to come out or is going to get updated. And that's like a big thing that I like to share, and why I like sharing my journey is because it's just that. The thing with school is great. I mean, I went to school, did the 4-year thing or whatever, but that wasn't the thing when I sat down at job one that necessarily helped. It was the baptism by fire of sitting at the desk and working. So it's you know, can you think on your feet? Can you think creatively? Can you read the white papers and research and all these kind of things and figure it out?
Now, a good class, a good thing to do to these students, drop a production database.
Oh, yeah.
And then see what they do. That's the class they should
The freak out.
Go fix it.
It's making me think of, if you all haven't seen it, I'll have to share it, but if you've seen where someone took a clip of Mr. Bean sitting in the theater, you know what I'm talking about.
Yes.
That's what would happen.
Yeah, exactly. So now that we've essentially riffed on the entire worldwide educational system, where should we go from here?
I hope my professors aren't watching.
I hope
But
my
it is
professors
really
aren't.
back to the point, though, that you know, I think everybody's getting higher and higher level.
Yeah.
And it's only natural that as people move up, that hardware has to keep up. And hardware unfortunately has limits. You know? I mean, we can't have 10 gigahertz processors in production, really. That's not practical. So what do we have to do? We have to have many cores. Well, we can't have, you know, now we've got, 144 core processors. Okay, what are we going to do? Accelerators. You know? It's like, we just keep having to roll out more and more hardware to keep up with it, right?
Right.
Yeah, throw hardware at the problem.
Yeah. And I guess that's what's happening.
Yeah.
We heard an interesting statistic at one of our tables at dinner last night, that the amount of AI-generated data now is close to or exceeds the amount of real data in the universe.
I did, actually.
Right.
Yeah.
Yes.
I made it up.
Seriously, you did?
No, I actually read that.
Okay,
but
good.
I don't know if it was a good source.
I got you.
Was it Reddit?
It was actually ChatGPT.
Telling you how important it is now.
No, it was not ChatGPT. But that is the world that we live in, where we're just awash in machine-generated data.
Yeah.
Right. And being able to filter that, we're discussing also the idea of something like a truth engine that would say, no, this is the original article, whatever it is. This is the original thought, however we would encode that. Well, I mean, that's going to take quite a bit of processing power. And however we're going to need to do that, right, to authenticate those things. So maybe we will need to continue in that world, in this mode going forward. I don't know.
Do you think that we're going to have people like to say that these things are cyclical. Do you think that we're going to have a move back away from distributed computing and accelerators and back toward monolithic compute? Or do you think that it's just going to be a whole world of accelerators forever?
I think there's always going to be a need for monolithic. Let's call it a mainframe.
Right.
There's always going to be a need for that. It's just the demand for it will probably be less and less over time. So I think distributed computing is the way to go, and that's going to have more and more growth.
Yeah.
Interesting.
Well, it's interesting because from an architectural standpoint, the reason the mainframe is so high performance and powerful is exactly because it has distributed processing engines for networking and for storage and for computation and so on. I mean, that's the original massively parallel accelerated system. But I get your point that basically if you know what I don't know, like an AI processing system is well beyond what a mainframe is. I mean, it's a different universe.
Yeah. Yeah, they're two different tools.
Yeah.
Yeah.
Do you think that that hardware is going to get too fast for software? Do you think we'll always be able to absorb it?
I think that, well, again, we're back to if developers could only write good code and could spend as much time thinking about what would happen if that failed and how mission critical it is if this thing, or didn't even fail, but just ran twice as slow as it's running right now. I think that that's the thing that, we're not really teaching people to optimize things. So yeah, it's not Moore's law. Isn't there another law about work expands to fill the time allotted to it? So yes, basically.
What do you mean by too fast?
Yeah, and what's too fast? Yeah, exactly.
Well, what I mean is so we were just we were just listening to Broadcom, and they're talking about networking and network switches, and they were saying 100 gigabit Ethernet, 200, 400, 800. 1600.
Right.
They're talking about all these terabit switches with many different ports, and one chip can process 64 different 64 times 800, was that what it was, or 64 times
No, times 400.
Yeah,
okay, 64 times 400.
32
That's a
times
lot.
8, yeah.
Right? Is that too fast, or is that just future proofed?
I don't think it's too fast, and I think it'll continue to get better.
Yeah.
No?
I think I lean towards future proofing versus being too fast.
I still don't know what too fast means.
Right. That.
Well, it's the same thing. The same thing with CPUs. How about 144 cores? How about 288 cores? Can you use 288 cores of processor? Well, I guess it depends on what you're doing with it, but that's an awful lot of processing.
I mean, if you're talking mining for Bitcoin, right? Which, by the way, I want to know if that SQL processing unit would help with that.
You're in my brain. Yeah. I wanted to ask, and
because if it does, because that's just an analytical workload, and if I'm just mining and I'm passing it through Spark and Presto, I think we got a new business plan.
Just saying.
This plan.
So back to the central premise. Let's wrap this up, and I'm going to ask you again. Do we desperately need to have all these new accelerators and all this new hardware because computers aren't fast enough?
Desperately need? No. I'm not even going to say computers aren't fast enough because we have ways around that where you scale out architectures. You can distribute things across nodes, right? So again, that's applying a solution to get around because there are hardware limitations. All the hardware does is move the wall. So instead, there's even the guys at Neuroblade say that. So instead of needing 100 nodes, you only need 3. But how long will that last? In 3 or 5 years, you'll be back. Now you need 10, 20 nodes again. And we'll be right back to where we are. So that's a qualified no, sir.
Yeah. I'm stuck on we need the DevOps equivalent between software and hardware. That's what we need.
And a name for it.
Yeah.
I think by the next field day, you should be tasked with that as homework.
Okay, that's my homework, everybody.
I'm an English major, but I can't even come up with anything that's going to sound something like DegSeg.
Why don't we use ChatGPT to solve this problem?
Because I'm a real creator. That's why.
Wow.
I'm authentic.
Wow.
You certainly are. Well, thank you very much for this fascinating conversation. If you're wondering what field day is really like, this is what field day is really like. As you heard, this is the kind of thing that we sit around talking about in the afternoon and the evening when we're at dinner, when we're on in the van going from place to place. And it's honestly a lot of fun to riff off of these things with people, especially when we have people who come from very, very diverse backgrounds in terms of technology and knowledge areas and areas of expertise. Because, man, the thing that I've learned is it pays to shut up and listen, because there's always people with really remarkable knowledge. So thank you so much for this. We are really excited with Cloud Field Day. It went so well. We've announced another one coming in June. You heard a little bit about AI in there. We've got an AI Field Day event as well. You should definitely check that one out. A lot of these companies are going to be presenting at field day events now. And also, I'm really excited to be able to continue Field Day with a whole bunch of different topics. We're looking at doing a data platform Field Day where we would talk about the stuff that Thomas and Jim like. We're looking forward to doing a DevOps Field Day, which would be something that I'm sure that you'll see Shala at. And honestly, we're doing some other topics too. So thank you so much for joining us. Before we go, where can we connect with you and continue this conversation and read your thoughts about whatever you're interested in?
You can find me on LinkedIn, Thomas LaRock. Actually, the LinkedIn/N SQL Rockstar will get you there. And you can find me at thomaslarrock.com. I sometimes still blog.
You can find me across all the social platforms as @GiftedLane, Twitch, X, LinkedIn, all of them.
And you can find me at jimthewhyguy.com on LinkedIn. Also, as Jay Czuprynski, I think it is. But just go to Jim the Why Guy, you'll figure it out.
Because they can spell that.
Yeah, it's too many consonants. And also, I'm not on X. I'm only on Mastodon because I was kicked off. So. What? Yeah, that's what I said.
That's a different podcast.
That is a different podcast.
That's the next one.
But I'm happy to say that Jim is hosted on my Mastodon server, the techfieldday.net Mastodon server.
Thank you, sir.
Oh.
I am also very, very, very much on there. So you'll find me at sfoskett at techfieldday.net. I still have my X Twitter account. I do a lot on LinkedIn, so you'll be able to find me there. And of course, with the Futurum Group now being above the Field Day organization, that gives us a lot more opportunities in terms of traveling and going to events and doing things. So you'll probably see me all over the place going forward. Thanks for listening to the On-Premise IT Podcast. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise, now part of the Futurum Group. If you would like to leave us a comment, we would love to hear from you. You'll find us in all of your favorite podcast applications. Give us a subscription. You'll also find videos of these on YouTube. Just go to YouTube/GestaltIT video. And we publish these episodes every week on Tuesday, but we also have a Monday podcast, which we're currently focusing on AI. That's called Utilizing Tech. And a Wednesday podcast where we do a rundown of the week's news. So please do check those out as well in the Gestalt IT feeds. Thanks for listening, and we will see you next week.